In this activity, students will build a simple spooled car powered by a rubber band. They'll learn to measure distance and use that distance to calculate efficiency. Efficiency is the amount of output you get for a given input. In this case, efficiency will be the distance that the car travels over the number of turns that we use to start the car.
Each student should receive one wooden spool, one nail, one washer and nut, a rubber band, and 2 craft sticks. To perform calculations, students will also need to use measuring tape and a calculator. Complete instructions for constructing the spool car are provided in the youth handout. To wind up the car, simply turn the nail. This winds up the rubber band inside the car. Be careful not to wind it up too much though, or the rubber band inside may break. To run the car, place it on a flat surface and let go. The goal of the students is to calculate the efficiency of their spool cars, and if possible, to make modifications to improve the efficiency. Remember, efficiency is defined as output divided by input. In this case, it's the distance the car travels divided by the number of turns used to wind it up. So, if I wind up my car 5 times and it travels 25 inches, the efficiency is 5 inches per turn. If students make modifications to their car, they should first measure the efficiency of the car alone, and then they should measure the efficiency of the car after the modification to see if the efficiency changed, and if so, by how much. Like engineers, students should always be looking for improvements that they can make. For example, they may notice that using a piece of wood or a pencil, rather than the metal nail, decreases the weight of the car and increases its speed. They may also notice that their car skids or slips when wound up a lot. They may try to prevent this by taking excess rubber bands and wrapping them around their spools as tires. The rubber bands will increase the friction between the spool and the ground and should prevent the car from slipping or skidding. This will improve the car's efficiency. Sometimes when winding, the craft stick may slip. This prevents the rubber band from being wound completely and decreases the performance of the car. To prevent this, you can take a piece of tape and attach it directly to the craft stick. This prevents the craft stick from slipping and allows the car to be wound completely. One important thing to note about taking measurements is that the first time you wind up your spool car, it will require more turns than each subsequent time. This is because when you let your spool car run, the rubber band doesn't completely unwind, and so when you wind it up again, it's already partially wound and it takes less turns. This means that students should always do a test run before taking measurements, since their first measurement might be different than all the others. This also means that students should not wind up their car in one direction, and then on the next trial, wind it up in the opposite direction, as this will cause the rubber band to unwind before it starts to wind again, and this will throw off their numbers.
As the students are making improvements to their cars in this activity, they're acting like engineers. Automotive engineers make many small improvements over time that improve the performance of their cars. Performance gains might be in faster, better acceleration, more torque, or more efficiency. In gasoline cars, efficiency is measured in miles per gallon. In the rest of this module, students will explore ways of making cars move, and, like engineers, they'll make many small improvements to those cars over time.